think uh, Previously we discussed how to create databases and tables.
Yes,
Also
yes.
inserted some records and also gave you some homework
Yeah,
to
I
do,
have
right?
done this. Yeah.
Okay, we'll see those. Before that, we'll discuss about some theoretical concept that we
Okay.
have in day one. Okay, so 1 minute. Hmm, Okay, so introduction to databases first we'll discuss. So where first we will talk about data. What is data? So data basically it refers to raw facts. First, we'll discuss about data. Small things, but we need to clear all the things. So it refers to raw facts. Okay,
Okay.
data is nothing but raw facts which will be in the form of numbers or text or symbols or multimedia. Which the form of text
Next.
or numbers or symbols or multimedia. Okay, so these are known as data. So, for example, if I ask you to give a list of names and phone numbers, so these are data.
Yeah.
All the names and phone numbers, these are data. Or number of steps you take in a day, that is
Yeah.
recorded by a fitness tracker, like that is a data. Or we are using social media apps. So let's say, for example, we are scrolling those things, or we are uploading some things, or we are deleting those things. So all those are data. Each day, data is getting generated through these apps and by our movement as well. So everything are data. Now we'll see characteristic of data. So first is raw data. Okay. So raw data, as I said, it will be in it will be in the form of unprocessed or unorganized information. So we need to process it. It will be in the format that is not useful, that is known as raw. It is our duty to process the data, but the data that we get from source, that will always in the form of raw data, that is not useful for us. Those are unprocessed. Okay, data which is unprocessed. What is the role of data engineer? To pull this data and apply transformation. Transformation in the sense to clean the data. But
Okay.
the initial form will be always raw. It will be in raw format or unclean data.
Okay.
Then we have quantitative or qualitative data. Quant or qualitative data. So what does it mean? Quantitative and qualitative means the data which will be in the form of numerical or descriptive. Okay, so for example, we have age. Age will be in numbers, or we have let's say number of employees. Those will be always in a numeric, or let's say employee salary, or let's say how many uh, people are there living in north region or south region. These data we call it as quantitative. Qualitative means descriptive data, like name. Okay, so let's say quant, which means ID and salary. Okay, or ID means not only employee ID, it can be product ID, order ID, any
Mm.
ID, right? Salary, employee salary, and let's say age and profit or loss. Okay, then revenue. All these are quantitative data. Three is qualitative data. Qualitative. Qualitative means descriptive. Quant means numeric. Numerical. Numerical. Okay. And these are descriptive. So for example, employee ID or product name. Okay. Product name, category or subcategory. So if we talk about
Alphanumerical
any
data. Mm.
alphanumeric, yeah, yes. So let's take an example of a product. Let's say iPhone. So product name will be iPhone. Category comes under mobile or it comes under electronic. Inside electronic, it comes subcategory is mobile phone. Okay. So like that we will be having. So this data, we have raw data, quantitative data. Then we have qualitative data. Then we have structured data. Okay. So structured data will be in the form of
Mm.
rows and column. That we
Table
call
form.
it as a structured data, tabular
Yes.
format, which is your relational database management system. So that is a structured data, correct?
Yes, sir.
Will be in the form of tabular. Then we have unstructured data. Okay. So unstructured data means uh, it will be not in the form of rows and column. It can be in any specific way, like we have text data or we have audio, we have video, MP3, all those things comes under unstructured. Then we have semi-structured. So we can have our JSON file. Okay.
Mm.
XLS file. So these are semi-structured. And one more thing is there, that is static data which does not change on its own.
Then
Like
how does it process that?
no, we need to make it dynamic. It will never change on
Okay.
its own. Okay.
Okay. Okay.
This is the main thing, on its own. So for example, college websites and school websites, once it got created, mostly, most probably in 90% of the cases, they're not changing their website. Okay.
Mm.
It will be as is until and unless we change it. But if I talk about Flipkart or these retail chain, okay, anyone, Flipkart,
Mm.
Amazon, those
Mm.
are dynamic. It keeps on changing on every 1 minute, you can see. You can see if you scroll Flipkart, if you open Flipkart now, you will see some products, iPhone product at the top of the page.
Yes.
Again, after half an hour, when you open Flipkart, you will not see iPhone product. You will see some other products because it keeps on changing.
Yes.
But the static data,
Understood.
it doesn't change on its own. We need, if we want, we can change it. It will never change on
Okay.
its own. Okay.
Yeah.
Then this is enough. Then like data. These are characteristic of data. Okay. Then we have types of data as well. Like for example, textual data, time series data, binary data. Binary data will be in the form of zeros and one, right?
Mm.
Numerical data, which can we can count it. So those are known as numerical data. Okay. Now we'll talk about database. database.
So
So
for database, actually we have to write out database means structured and non-structured actually.
correct,
Mm.
correct.
So we will cover both or
No, no,
one.
only relational, only relational.
Okay.
So first we have a relational database. Second we
Mm.
have non-relational. Okay,
Okay.
or no SQL DB. No non-relational, or we call it as no SQL DB. So this relational database, okay, these use tables,
Mm.
relational databases, and structured relationship to store the data. For example, now we are learning MySQL, correct? So that
Yes.
is a relational database. Then we have Post, Postgre SQL. We have Oracle. All these comes under uh,
Yes.
SQL Server, relational. Yeah, all this comes under relational database. These will be in the form of rows and
Table.
column in the tabular
Mm.
format.
Yes.
Then we have NoSQL database or non-relational database. These are used for unstructured or semi-structured data. Okay, so relational database is for structured,
Structure.
and these are for
Structure.
unstructured or semi-structured. These are used for unstructured or semi-structured, and it includes types like document stores or key value store. So
Mm.
JSON format, it will be in the form of
Mm.
key and value.
Key values. Yeah.
Uh, so we have popular one, that is MongoDB. Then we have others as well, Cassandra, and in Azure as well we have Cosmos DB. Okay, Azure Cosmos DB. So in our course, we'll cover only a relational database. Non-relational data will not cover, because so far I have not implemented NoSQL yet, but it
Okay.
depends on organization to organization. So for now, we can take relational database only. Okay. Now, uh, since you already have worked on and the databases, you know what is the importance of database, correct?
Yes.
Why do we need a database? Previously, when we didn't have database, what people were used to do is to maintain a sort of register or diary. There they were maintaining. For example, if you go to police station, maybe uh, uh, 20, 30 years back, even I don't know, but by referring to these books and all, we got to know that they were maintaining when computer was not developed, database was not developed. So they were maintaining in a register. There they were. The problem was it was having some duplication issue. Okay,
Yeah. Yes.
and if I ask you to get the data for 1994, let's say for example, they have to open some register which maybe they would have or not, that also not sure. If
Yes.
they find 1994 register, again they will have to go page by page to find that particular person name, correct?
Mm.
But with
Mm.
the use of database, we can just writing a simple select star from table name, and we give any filter condition where date or where year equals to 1994. Then we can within I can say within 30 seconds we can get the desired output using
Yes.
databases. That was
Okay.
not possible using that file management system. Previously we had file management system.
Yeah.
So what are the importance of databases? So importance of the DBs is one, we can get quick access. Second is we can avoid mistake. Mistake in the sense databases are good at preventing mistakes. They can make sure
Yes.
you
Yes.
don't accidentally sell the same toy twice or make the pricing error. Okay,
Oh
so
yeah.
those
Mm.
we can avoid. We can avoid the duplication as well.
Mm.
These things. Okay. Then if we have the data, we can generate reports as well using any of the BI tool,
Yes.
and we can send to our um, I mean senior management level because don't have time to see the data cell by cell. Or they will only see the reports and reports
Mm.
and all dashboard. So if we
Yeah.
have the data, we can do these things. Okay. Then we have DBMS. All these we were talking about databases. Now we saw types of databases as well, relational databases and importance of databases as well. Out of these things, we have one thing, DBMS, that is
Mm.
database management system. We saw the databases, we saw the data, we saw the databases. Various types of databases are there. These are databases. So databases, database management system. To manage the database,
Mm.
we have DBMS. Okay, and then since in this course we'll talk about relational database. Now let's see relational database in the. I mean, I can write this as it's a software which is used to manage the database. Okay. Now we have a relational database. So or RDBMS. Okay. It stores structured data and establishes a relation between the data. That is why it is known as relational database. It establishes a relation between the data. Okay.
Yeah, understood.
Hello. Hello.
Yeah, yeah, audible. Yeah.
Hey, what happened? Call got dropped.
Actually, my network is good. Actually, my network is
Okay, let me reshare it. So I was saying a relational database. So
yes.
RDBM stores structured data and establishes
Stop.
relation between the
Between
data.
them.
That is why it is known as a relational database. It will establish the relation between data. So we'll see one example. Okay, so for that, let me open Excel. Here, let's say for example, we have employees table. Okay, where we
Yes.
will be having employee ID, then let's say EMP name, and then city where the employee belongs to, and their designation. Okay,
Yes.
so employee ID, let's say for example, PDL 001, PDL 002, like that we have. Then employee name, let's say for example, Then we have, okay,
mm,
city, let's say one is Bhubaneswar, one is Cuttack, let's say. Then destination, this is fine. Okay, data engineer, EE, data engineer, like AD, Azure data engineer or software engineer for now. Okay, fine.
mm,
So this is a simple data of an employee.
mm,
Now we will create one more uh, table. Let's say, for example, we can say
department.
department. So here we will be having department ID, DEPT, department ID. Then we have department name
Mm,
and location. So here, let's say department ID is 1 and department name is delivery
mm,
and location, for example, this is Bangalore. Department ID is 2. This is ops, operational. And this is, for example, Chennai. Okay. Now we'll be having one more column, emp ID, employee ID.
mm,
Here it will be like VDL001. It will be in the same format, employee ID. Okay.
mm,
Then we have VDL002. Now, if we don't have, for example, now let's remove this. Okay. Just assume we don't have this column. Now, if I ask you that Jagan, okay, I mean, by seeing this table, employee table, we
yeah,
can know that Jagan is living in Cuttack and he's a software engineer living in Cuttack. Okay, fine.
mm.
But can we get to know what is his department? No,
No,
right?
no, no.
No. Then if we join these two tables,
Yeah,
okay, now let's join these two table, assuming this column is not there. Still, can we get the department of Jagan? No, right?
no.
Because
There are no
department name
relations.
is correct. There are no relation between these
Yeah,
two tables.
it's
So
clear.
now when we join these two having one primary column, okay, primary key column, that is our employee ID. Now
Yeah,
we can make a relation between these two tables,
yeah,
okay, using this employee ID. Okay. Now if I ask you what is department name of Jagan, we can easily say that VDL002, we can look for into this department table, VDL002, and we can see the department name is operational. Then we can say. So
yeah.
these two tables are creating relation among each other. That is why these are known as relational database management system, or DBMS,
Yeah, understood.
right? Similarly, we can have multiple examples. Let's say we have one customer table or order table. Okay, because mostly all the example I'll give you related to retail chain, because at the end we'll create one retail chain project.
Yes.
Okay, and that is also nowadays it's popular for retail chain only. So we'll talk about retail chain only. So let's say for example, one table we have for customer, another is for ordered. Okay. So customer, we can have customer ID, customer name, then billing address of customer, shipping address of customer. Okay. These attributes maybe we'll be having. In order means order ID. What is the order ID? Then order date, right? Okay. One second. For example, we have one customer table and customer orders something, right? So then we have
Yes, sir.
order table as well. So in
Yeah.
customer, we can have customer
Customer,
ID, then we
customer.
can have customer name, ignore the typing and all. Okay.
Yeah.
Then we can have billing address, ADDRS. Okay. Then we can have shipping address. Similarly, for order, we can have order ID. Okay.
Yeah.
Then we can have order date or
Yeah.
order date. Then we can have shipping date
Yeah.
and order status. also we can have.
Yes.
Okay, but one more thing we need to add is customer ID, so that we can make the relation
Yes.
between these two table.
Customer and
Customer ID. Okay, we'll make a relation.
yeah, I understand.
So this is our RDBMS or Relational Database Management System. Okay. Uh, Types of databases, asset properties, introduction to SQL is there completed. Then, okay, before going to asset property, first we'll see component of SQL. That is important. Component of SQL. Okay, fine. Mm, okay. So see, we have some components in SQL. Okay. So first is DDL, or this is also known as data definition.
Language.
eh, Data definition language. By the
DC.
name itself, it suggests it is used to define it. Okay.
Yeah.
Data
Yes.
definition language is used to
Define.
define the things. So how can we define the things? By using one, we have create statement. Create means we are trying to create anything. Either we will create a database or we'll create a table, which means we are
Yeah.
defining the schema. So create is
Yeah.
used to create database objects. DB objects like tables or views or indexes. These things, schema,
Mm,
this thing will create using
mm,
create statement. Then we have alter, right? So alter is basically where,
mm,
let's say for example, you have to delete any column from the existing table, or you need to rename the existing table, or you need to change the data type of existing column in a table, particular table. You need to modify something. For those cases, we are using alter, right? So this comes
alter.
under DDL statement. Then we have drop. You want to drop something. You want to drop database objects like tables, views,
Columns. Yeah.
indexes, anything, columns. Yeah, these we can do that using drop statement. Then we can use truncate. So truncate will remove all the data from your table, but it will not delete the schema,
We can roll
right?
back. Okay. Yeah.
It will never delete the schema. It will only delete the data. Went out.
No, no data.
Okay. Then we have DML, or data manipulation
Data manipulation language.
language. Okay. So in DML, manipulate means to fetch the data. Okay. So to fetch the data, first is select.
Select.
Select. So we can retrieve the data from one or more tables using select statement.
Yeah.
Retrieve the data from one or more tables. Then we can have insert. Insert will add a new record.
Yeah.
Then we can update it. Update table,
Certain
which
cuts.
means, yeah, it will modify the
Yeah.
data. Then delete also we'll use here. So delete will also remove the records from a table. If we don't apply the filter, it will delete completely. If you apply a filter, then it will delete some specific records. That is another thing. We'll see that. but delete
Mm.
is used to delete the records. That only we can now know. Then we
Yes.
have, see, these two are, one more thing is DCL is also there. So first talk about DCL. DCL means data control language. Mostly we will use this DDL and DML statement.
Mm.
Most of the cases we'll use DDL and DML. DCL and all are very rare. Actually, this DCL, we are, as a developer, we will not do it. We have platform team in MNC. We have platform team, administrator team. They will only do these things because we mostly will be having reader access only. Don't have admin access, but still we should know. One is grant, another is revoke. These two statement we have under DCL. So grant will give you a specific privilege to user,
Mm.
will give.
Specific privilege.
These are not our things.
The
These will be
deviating.
these will be taken care by other teams. We should know these things. And revoke just opposite. It will remove. Sorry, it's just opposite. It will remove
Specific privilege.
specific privileges. Okay, fine. Uh, then we have
DQL.
DQL. In DQL also we have that select statement. So primarily used for querying and retrieving the data. They have segregated DQL. Actually, DQL is not needed. It's all same as DML select. So both are
Mm.
similar only. So let's skip this. We have one more important, that is TCL,
Mm.
external control language. Okay. So in TCL we can have commit.
Commit and rollback.
Okay. So commit means it will save all the changes which
Mm.
will be made during the current transaction. And then
Yeah.
we can have rollback. Rollback means it undoes the changes made during the current transaction. Okay. So okay. So first we talked about DDL and all, DML, DCL. All this comes under components of SQL. And these DDL and all, these are kind of language.
Statement actually.
These are statement. Okay. Now we have other things as well in SQL. Not only these things, we have other things like we have keys, right? So those keys and all comes under constraints, SQL constraints.
Mm. Unique standard primary constraint.
Yeah, those things, correct. So one is primary key. First, very important is primary key. So what is primary key? So it ensures unique value in a column,
Yes.
right?
Yes.
It it will not allow any null values,
Mm.
right?
Yeah. Yeah. Yeah.
So
Understand.
first is okay, fine. Then I can skip this. Then second we have foreign key. Foreign key. So it will establish a link between two tables.
Mm.
You know,
Yeah, I know.
okay. So we have two table. Here also we have one primary key, and here also in order table also we have one primary key. So now this primary key will act as a foreign key for first table.
Mm.
So
So
we are in
to make a relationship between two tables.
between two tables.
Mm.
Yes. Then we have
unique key, unique constraint.
unique key. It will also ensures that all the values in a column are unique.
Yeah, unique key.
Then what is
It
the
is. Yeah,
difference between primary and unique? Any idea?
yeah, primary key always allows the unique value in the table.
It will also allow the unique value.
Mm. Primary key does not allow the null value. Mm.
Correct. Primary
Unique
key
we
doesn't
can
allow null value, but unique can allow the null
we can
value.
yes,
Then we have
check
check
constraint.
means
Check
it will check
yes.
for a
Yeah,
certain condition. Let's say, for example, we are creating a table wherein we want to store the employee, not let's say students
yeah,
whose age are greater than 18. Let's say we want to um, provide them some driving license, or let's
yeah,
say 18 years voter ID and all. So those
yeah.
tables when we are creating, we will create some checkpoints. If they are greater than 18, then only we will store the data, else we will
We
not
have
store.
to put one condition
Condition,
before
yeah,
insertion.
correct. So that we will see. We will create all those things. We will create the table when we will create the SQL table. We'll
Yeah,
use all those things, okay, all the SQL constraints. Now, theoretically, just understand what is the use of these things.
yes,
Then we have one more thing, that is default. Default means while inserting the data into a table,
if you're not
uh,
if you're not giving any value for the
value,
given call, then it is
then it
taking the
will
default value.
the
No,
default value.
actually,
Hmm, right, okay. Then we have views. Okay, in SQL we have tables. Table we will store the data.
yes,
Then we
yes.
have views. Okay, views are nothing but a virtual table,
Mm,
which will we will create as a result of select query.
yeah,
Right, it is a virtual
um,
table,
yeah,
which means it doesn't stores anywhere physically like a table.
yes, yes.
It's a virtual.
Mm. But
Okay.
can you please brief on this view and index? Actually, I forgot actually
Yeah,
something.
I mean, see, we will when while creating the things, we will create it. Views is one is table, one is view, one you are saying index. Okay.
Yeah,
So table we will store the data. Okay.
yes,
And when we store the data, obviously it will consume some spaces. So let's say it consists of millions of records and the size is 1 GB.
yeah,
Correct?
yes. But it's stored
Okay.
physical actually.
It is stores physical. Okay. Uh, Views. It's a virtual table, first of all. And we will create the views using select. We
Yeah.
have like
So is there any types for options?
create or replace view as select star from table name. This is the syntax of creating a view. Okay.
Yes, yes.
Now, after creation of view, you will see, let's say for example, we had this table employee. Now here also you will get the view for employee with 100 with millions of records. But when you see the size of view, okay,
Mm,
it will not show any size. Why? Because we are not storing the data physically. It's a
okay.
virtual table. It
Yes.
will never show the size of a view.
Okay.
Second thing, if you want to update our table, okay, let's
Yes.
say you want to modify your table, you can do that. Update in view. No, directly, which means we cannot update our views
Yeah.
directly. First, we need to update our table. Okay. First, we need to update our table. Then we will update our views as well. See, in views as well, we have to, some views, let's say materialized view, it will update automatically. But the normal view will not update automatically. We need to update it manually. Those are view. It will never show you the size because we are storing it as virtually. And in a table, let's say you have 10 columns. Okay. You have 10 columns and you want to share these 10 columns or in this table with other department. Let's say you want to share with HR department. Okay.
Okay.
But out of these 10 columns, you found that some of the columns are very, PII data, personal identifiable data that you don't want to share with somebody else. PII data.
Okay.
PII data means, which means
Mm,
employee phone number
okay.
or employee email ID. These you don't want to share with
So,
somebody else. Now, what you will do if you share the table name, let's say table name is employee, then HR will also get to know the employee phone number and email ID, correct?
yes.
We don't want to do that. So what we can do, we'll create a view wherein we have an option. Either we will send only 10 columns, sorry, only 8 columns. 8 columns. We will store only 8 columns in a view and we will give it to HR department.
It's in
This is one way, correct?
yes.
This is one way to secure
Mm,
our phone
phone
and email
number and email
IDs.
ID.
Second is we can do data masking on phone and email ID
ID.
and store in a view and then
Mm,
we will send to HR department. Data masking in the sense mobile number will look like something like star star star
yes.
zero like that. Similarly, email ID will look something like this. So they
Yes.
can see this value in
And then,
respective
mm,
columns. Correct.
yeah, yes.
So that is the reason we are creating views. Views are very powerful and very useful in terms of security and all. And it doesn't contain any physical data. So these are difference between tables and view. Now, related to index, index is it's for example in a book. Okay, let's say we are reading something database and algorithm. Let's say hashing algorithm. That is in page number 55, for example, under section 3A, page number 55. If I ask you where a hashing algorithm is there without seeing the content, which is content page
Mm,
will always on the first or second page, correct?
yeah. Yes.
Uh,
Yes.
there you can navigate. You can see that DSA or hashing algorithm is
It's
in page number 55.
25.
Okay, merge sort is in page number let's say 65. Then we
Yes.
can directly navigate to page number 65 instead of checking all the pages.
Yes.
Same case is in databases as well. If you want to quickly retrieve any data, so we'll define some indexes.
Mm,
Indexes based on any column. Let's say our column name is year. Okay.
okay.
So based on year, we want to retrieve some values. So using indexes, we can quickly get the values. Or else it will take some time. If we don't define any indexes, it will take some time.
Okay.
So
Understood.
that is the use of indexes.
So basically, you have to give some condition or get the quick result.
To get the quick result, we will create some indexes.
Okay.
Okay. Then we have store procedures.
Uh, Will you cover
Just
all these topics later or
yeah. All
okay?
the topics, all these
Okay.
topics.
Okay.
Okay. Then we have store procedures. Okay. So store procedures are, these are predefined SQL queries that can be executed with parameters.
Okay.
So it's a kind of function. If you know Python or C, C++, Java,
Yes,
so
sir.
you know function, it's a kind of similar thing, store procedure. We are
Mm,
defining the procs and then we are calling those procs. It's a block
mm,
of SQL statement
mm,
to do some task.
mm.
Those are store procs.
Similar to
Then
PLSQL or is
similar
different?
to PL. Yeah, yes, similar to PLSQL.
Okay.
Then we have triggers. Trigger means it's a kind of, I can say it's a set of actions that will automatically executed when a specific event occur. Let's say, for example, you inserted some um, record in a table, then a trigger will automatically calls. For
Uh,
example, you are going to ATM and you are withdrawing some amount, let's say 3,000 you withdrawn from your account.
mm,
Automatically you are receiving a message
uh,
like 3,000
mini
has been
statement.
deducted.
Yes, sir.
Correct?
Yeah.
That is what it has generated one trigger and that will
Okay.
get stored in a table. Transactional data we are storing in relational database management system. That we are storing in a table that later we can see. We in the sense bank department, they will see the records and all. If you want to, if you ask them to find something, they can quickly fetch from that those tables and all. That is a kind of trigger.
Yeah.
In ADF also we'll see if, let's say for example, you're doing one thing on daily basis.
Okay.
You are running a job. Your job is, what job is doing. It will pull the data from, let's say for example, SAP. The source
Yeah.
is SAP. It will pull the data, and then it will clean the data, and then it will store into some warehouse.
Yeah.
Every day you are doing the same thing. So instead of running that job manually, what we can do, you can trigger that job. Trigger in the sense we're calling. Okay, we can run that job automatically by
Okay.
scheduling it. So we will see those scheduling and all other. Those are other concepts. But trigger is, it's a kind of set of action that you are doing on daily basis.
Okay.
Okay, that we can automate this. Then we have subqueries. Subquery, query inside the query that is known as subquery.
Yes. Yes.
Then we have joins. If we have multiple tables, we need to join like we saw just now. We had two tables. We joined these two
Yeah.
table, employee department or customer and order. That has
Yes.
joined. We have different kinds of joins that we will see later. Okay.
Okay.
Then what else? We have grouping. Aggregate functions.
Aggregate functions. Yeah.
Aggregate functions are the functions which will take multiple inputs and give one output, like min of 10, 20, 30, 40, 50. It will give you 10, correct?
Yeah.
Max of 30, 40, 60. It will give you 60. So it will take
Mm.
multiple inputs, but will give only one
One,
output.
one port.
Then we have sum,
Understand.
count, right? Those are aggregate
Excellent.
functions.
Yes.
Then we'll apply the grouping. Group by also we can do with group by. We can use having, right? We have some clauses, SQL
Yeah.
clause. We have where clause. We have having clause,
Having
right?
class. Group by
Having
class.
clause. Then we have group by.
Partition by also.
Partition by is also there. All these clauses also we will see the upcoming session. Okay, now I think we can discuss this thing.
Window
Asset
function.
property, window function. No, window function will cover. Window function is also there. So we have window function which will create a window for us. Okay, which will create another window for us.
Mm,
Create a new window. So we have lead function, lag function, lead, lag. Okay,
mm,
then 10th value, then row number we have.
Roll number, roll ID.
All these we have, we will see when we learn window function.
Yeah,
Okay,
okay.
fine. So let's talk about this asset property today. Okay, so asset property. So there are four crucial, I can say crucial properties which defines
Okay.
relational database transaction. One is
Okay.
our
See.
asset property. Asset means atomicity. C means consistency. I means isolation. What else? D means dura- durability.
Yeah.
Okay.
Right.
So, okay. So here, one is atomicity. So atomicity means the entire transaction. Whenever we are doing any transaction, so that's the same example. You are withdrawing or you are sending some amount to your friends or colleagues. So atomicity means the entire transaction takes place at once or it doesn't happen. For example, you want to send some money, let's say 5K you want to send to your friend. So either complete 5K will go to your friend's account or it will not go to your friend's account. It's not like you send a 5K and it only goes 2.5K. It will never happen, correct?
Yes, yes.
Either complete 5K will go or zero rupees will go, correct?
Yeah.
So atomicity means the transaction, you are doing a transaction, you are sending rupees 5,000 to your friend. So your friend will either get complete 5,000 or he will not get any rupees. But
Yes.
it cannot be like it will, he or she can get only 2.5K or 3K. So
Yeah.
the definition for atomicity is the uh, entire transaction takes place or does not happen at all. Now you see, whenever we are sending amount to Google Pay, sometimes
Yes,
it
sir.
happens that the end user are not receiving the amount, right?
Yes,
So
yes.
it will be in processing. It will show as processing and all. So
Yes, sir.
that might happen, but it will never happen that only some amount they received and others don't know. It will never happen. Either they will get the full amount or no amount. So that
Yeah.
processing amount comes under Google Pay processing amount comes under this atomicity. Either the complete transaction will happen or doesn't happen at all. Okay, then we have consistency. Consistency means the database must be consistent before and after the transaction. So for example, in databases, which is your table, your amount table.
Mm.
So before transaction, BT, okay, before transaction. This is after transaction, AT, after transaction. So let's say in your bank account, previously you had 10,000 rupees and you send your friend to 5,000 rupees. So before transaction, amount was 10,000. If you send 5K to your friend, it should show as 5,000 rupees.
Mm.
Correct?
Mm.
This is consistency. It should not show like 6,000 or 2,000 and all.
Mm.
It should show as 5,000. So the database will be consistent before and after transaction.
Yes.
Third is isolation. Isolation means multiple transactions can occur independently without interference. So which means at the same time, okay, multiple transactions can happen. You can do at the same time. You can do net banking.
Yes.
You can do mobile banking at the same time.
Yeah.
Even at the same time, you can withdraw some cash from ATM. Same time, at the same time, you can do all of these things, which means multiple transactions can happen independently without any interference. That is known as isolation.
Understand.
No doubt, right? So far,
Mm.
the database must be consistent before and after the transaction.
So, so the definition is database definitions is like this only, or is the example of example of this
No, no,
AC property?
these are definition and example. Same only.
Okay.
Example, you can give any example. I'm taking
Mm.
the transaction data. You can take any example. A definition, you will see these are the definition only.
Yeah.
Then we have durability. So durability is nothing but whatever changes we did. So the changes of a successful transaction occur even if the system failure occur. Okay. So let me write the definition first. 1 minute. This is the changes of a
Yes.
successful transaction occur even if the system failure occur. Whatever you did, okay. Let's say you sent amount 5k rupees to your friend. You sent it. Okay. So previously you had 10,000 rupees. You had 10,000 rupees you sent. Now it should show 5k in your bank account. Okay, in your table. Now this thing will happen. The changes of a successful transaction. It was a successful transaction, right? So these changes should occur even if the system failure occur, which means so this is target table. Okay, TARGT target table. It will be I mean handled by which team? It will be handled by bank only, not us. Okay,
Yeah.
so these table are handled by bank only. So let's say for example, banks are having some desktop. Okay,
Yeah.
where they are handling this. So now what happened? Previously you had 10,000 rupees. Now you sent 5,000 rupees to your friend. Now if this desktop, I mean, let's say it hung up, or let's say anything goes happen. Let's say a power failure was there from bank side. Anything goes happen. We don't know.
Yeah.
Any
Okay.
natural calamity happened. Anything happened. It doesn't
Yeah.
matter. If you have a successful transaction, then it should automatically get stored in the target table as well. That is the definition of durability. Even if the system failure occurred, it will show the changes in the target table.
Understand. Yes.
So this is very important concept in relational database. In non-relational database, you will never find these concepts. That is the reason all the banks, SBI, ICICI, any bank, okay, all the banks are using RDBMS because of this ACID property. They are not using NoSQL. They are using RDBMS. This is the reason. This is only the reason. It provides ACID property. This is very useful.
Yeah, understood.
Okay. Right. SQL constants, SQL keys. Okay. Data types. So we have some data types in all the programming language. We have data types, correct? So we
Mm,
have integer.
Just tree.
So we have integer. Then we
The-
have decimal. We
Yes.
have string. We have boolean. We have date type, date. Here we have numeric as well. Here we have date and time as well. So these are some of the data types which we have in SQL. Okay.
Yes.
We'll see this when we create the tables. We'll see these things as well. Now let's
Yes.
quickly create some table and we'll see. So now we will create normal table wherein
Mm,
we will not include any SQL constants.
okay.
No SQL constants. First, we'll try to create normal table without using any SQL constants like primary key, foreign key, and all.
Mm,
Later, we will
Later.
recreate the table using SQL constants. So two ways we will see those things. Okay. So as I told you, first is your database, right?
Mm,
Inside database, we'll be having schemas or tables. So first step is to create tables. Oh, sorry, databases.
Database.
Before that, I just want to see how many databases are already exist. So I'll write show databases. Okay, and I can see these are
Mm,
some of the databases which we have. I
mm,
also had created some tables like this.
Inside the
Sorry, database
database.
I created. No, these are not databases. These are
Tables.
sorry, these are databases, not tables. Some are by default databases. Okay, some I have created. Like MySQL is default one. Performance schema is default one. Sakila is default one. Sys is default one, and some I have created. Okay. So now we will create one database. So for that, I can write
Create.
create database
Name.
uh, cloud DB. Okay. So now again, I will run the first one. I can see
Mm,
cloud DB. Right, it got created. Now I want to create a table. Right. So I'll write
Create table. Table.
create table, table name, employee, followed by
Column name.
column names. So I'll write employee ID. It will be integer data type. Then we have employee name.
Name.
It is a
And then
string,
name. Sorry, name.
string.
Character.
So char,
Okay.
and in char we need to specify the size as well. Okay. So I can write employee
Last name.
employee first name. Okay. And then employee last name. It will also be in char. Then uh, year of experience. Okay, YOE, year of experience. It will be in decimal. I think later we can add this. For now, even I can remove this as well because I need to insert more. So that's okay. Okay. If I execute this, the compiler will not show, right, in which database the compiler create this table. So we need to mention that use our database, which is CloudDB, correct? So this I will execute, and now we are inside this CloudDB, and we'll try to, when we execute this statement, create table, it will create a table inside this CloudDB. Okay, so let's run this, and we can see the schema describe followed by my table name. So see, this is the schema of our employee table. Now we will quickly insert it. Okay, yeah. In the side by side, I can tell you the comments as well. In SQL, I think, right? So already you working on Oracle. So here I can write creating database and I can comment this. Okay, this is single line comment. Okay, this is single line comment. And here also I can inserting data into the table. Okay, insert into table name. The table name is employee values. A value employee ID. Let's say one. ID is one. First name, last name. Okay, this is fine. Then let's run this. Then I can write select star from employee and I'll get this. Right.
Yes.
Okay. Now I need to this is fine. I need to add one more column. Okay. Add one more column. How do I
Alter
add it?
table, alter,
Alter
alter
table,
table, table name,
table name,
add, add
add
column.
column name. So let's say I want to add year of experience. Okay. And then I can give
Yes.
decimal. Okay. Data type. And decimal actually we need to define how much size. For example, we have salary, right? Salary is kind of
Yeah.
0.89. This is the salary, correct?
Yes.
So complete, this is how much 4 plus 2, 6 characters. So we can define 6 comma 2, like that we are defining, which means out of the 6, 4 will be having left side and after decimal 2 digits we want.
Yes.
So but
And
year of experience we can define like uh, 2,
it's
3,
last.
2 and 1 I believe. Person can have 1 year of experience, 2 years of experience, or
Yeah.
3 or 30 years of experience. Maximum 2 digit, 30.6. Okay, 3 comma 1. Or for now, we can make it as integer. I'll tell you this later when we use SQL constraints. I'll keep this
Yeah.
as simple for now. Alter table name and column name.
But
Okay, fine. Integer. Now let's
yeah,
run this. Now again, if I run this select star,
it's
okay,
updated.
I will I can see this, but it doesn't
Yeah.
have any value. It is
Yes.
null. Correct. Whenever
Yes,
we
yes.
add any new column, the
It
value you
is
will see as null.
by default no.
By default
So
null. Now we need to, yeah, go ahead.
how we can directly
Update.
keep the directly keep this value inside this
No,
while
no, directly no, we can't. First we need to create it, then we need to update it.
yeah,
Now we need to update the table, update the value. How can we update? Then we have
of the table
update table name,
yep,
set YOE
x
equals
y
to, let's say for example, 10 years of experience. This is fine, but before executing this, let me add one more record. And let me run this. What happened? Can we execute? Insert into two Mohan BLS. Column count does not match. Oh, okay, okay. Got it, got it. Uh, year of experiences. Eh,
otherwise you can
Okay,
put a
fine.
null
And null also we can pass. Yeah.
no, no, actually, also while we are creating in the column, you can also mention the null.
Sorry, I didn't get you.
And so you can also add the null keyword. You know, while we are creating the alter one new column we added. At that time we
Correct.
can
Here,
execute
here only.
preview.
Your voice is not clear.
Yeah, maybe. Yeah, actually, whenever we were creating the column, no, new
Yeah.
column created.
Mm-hmm.
So after writing the add YOE integer, then we
Uh,
can write null also.
null,
If
yeah,
if
yeah. So that is,
if you don't get any value while insertion, then it is automatically takes the null value.
correct, correct. That we can do it. Now see, we have this table. Okay, we want to update it. Now we want to update the year of experience as 10. But to which employee? We have two employee, right? Then we need to pass some condition
Yeah,
where employee
employee.
ID equals to 2, for example.
Yes,
So we'll execute this. We'll run this. So we can see it got updated. Only this got updated, right?
yes,
Now we want to remove this year of experience. Okay, how do we remove it?
remove
Alter
alter
table,
table
table name,
remove
drop,
delete. Sorry,
no, not drop,
drop
drop column name.
column.
Done. Now if we run this again, select star, it will not show that column name. Correct. Okay. What else? I gave you some task, right? These are only tasks which I'm solving. What else? What else? You completed your task, right?
Yeah, I complete that. And one more thing actually, I have to in add using add keyword actually we are creating one God,
Few.
what yeah view actually.
Mm-hmm.
So if I delete the
Table.
parent table, then it is reflected in a view table.
Correct.
I have also done this. Yeah,
Okay,
yeah,
okay, okay. Great. So no doubt, right?
no,
Okay. Then great. I think So I'll cover the SQL operator tomorrow. Okay.
Yes,
Tomorrow we'll see SQL operator like and wildcard,
yes,
where clause, where already completed, but that's okay. We'll cover tomorrow SQL. Commit and
which
rollback I'll cover. This delete drop truncate, okay. I'll
yes.
cover tomorrow. Tomorrow only I'll cover.
Okay, and then tomorrow which time we will start this class?
Uh, one second. See, I have some work tomorrow. I need to go to somewhere
Okay,
around
otherwise,
10. Either we can start, if I will available, then we can start at 10.
okay,
That is less chances. Or in
okay.
the second half, when you are available.
Yeah, tomorrow I am available. Actually, tomorrow is week off.
Correct.
As for your convenient time, can take class.
Okay, then I will ping you. Okay.
Okay, see.
Most probably we can connect 3 p.m. Is this fine?
Yes, yes, yes.
Three,
Okay.
4, 5, 6, 7.
Yes, yes. Second half I am available. Also. First half. Not.
Okay. First up, you are available or not?
Yeah, I'm available whole days.
Okay, whole day. Okay, then tomorrow morning I'll ping you. Okay.
Okay, see.
Yes. Any doubt so far?
No, no, no. I will. Uh, I will learn today. Even doubt.
Learn today and try to learn about like and wildcard.
Okay.
Like operator we have, right?
Yes.
That you can go through. Alias as well. Alias is simple thing. Case
Yes.
statement and SQL operator. Only these things you can learn about.
Okay, see.
Okay.
I'll learn after.
Yeah. Okay. Yeah. Thanks. Bye.
Okay.